Hello to you now, and welcome back to our Learning Together series of math lessons or math discussions. And we started on Tuesday where we covered fractions, decimals, and an introduction to percentages. And that was laying the foundation. And today we're going to continue to build that foundation. So today we're going to be focusing on percentages, ratios, and proportions. So on Tuesday we did fractions, decimals, and an introduction to percentages. Today we're going to continue on that spectrum. I just want to introduce you to a little symbolism that we share right here in this class. It's the concept of a train, in suggesting movement, like a traveling, a journey. And I want to say to you that I feel like we're on a journey together. And as we travel along, we're going to learn some things as we travel. So the idea is, in life, you need to be on the train. You need to be moving. You don't want to be stagnant. You want to be always progressing, because that means you're growing in the process. So the presentations that we're doing are intended not only for students, but also for parents. You're home wondering, I've seen some things years ago, and I just want to just refresh and see what I remember, and just be excited and just be thrilled just to sit back, because you don't have a test. So you have the easiest arrangement where you could just look, be reminded, and smile, okay? So here we go, percentages. We're going to try and use percentages to do different types of things. They are actually absolutely common in almost every aspect of our lives. For example, if I was asked to find 20% of, say, 70, just like that, find 20% of 70. There are many ways of doing this. And my goal is to make it as simple as possible so that the beginner can understand. But trust me, I can make it complicated if I want to. So just bear with me. The important thing is, at the end of the journey, we know how to find a percent of something. So find 20% of 70. My recommendation is you always put 70 times an expression that takes into account what 20% is. Remember, we discussed that the whole is 1, and when dealing with percentages, the whole is 100%. So 100% covers the complete thing. So in this case, 70 is going to be 100%, and you want to find what is 20% of this. So what is 20% as a fraction or as a part of 70? And the way to do it is to multiply 70 times 20 over 100. It's 20 compared to 100. This is 100%, but we're looking for 20%. So it's 20 out of 100. And then we just need to simplify. 2, this cancels that, and 2 times 7 gives us 14. So 20% of 70 is just 14, okay? Now, another school of thought says that in order to find 20% of 70, you multiply 70 by 0.2. And you say to yourself, where did that 0.2 come from? I'm glad you asked. If you were to do a sidebar right here, or a sidebar, let's do it right here. 20 over 100 is actually equals to 0.2. You move the decimal point 1, 2 places. That's where the 0.2 came from. Same thing, it's just that I like to show that relationship so you can compare, okay? Let's try another one. Instead of doing something as straightforward as that, why not try and do, say, for example, if I ask you what is 12.5% of 320? 12.5% of 320. How do we do that? The process does not change. And this is one of the things that I want us to get accustomed to, recognizing that once we have the correct process, stick with the process. If the process works, stick with it and just be careful to make sure you finish the job. So we said that we take 320 and multiply it by 12.5, whatever the percent is, put it over 100. And then from here, you take your time and go through and get the job done. If I was doing this, I could say 0 here cancels this. I could also say 2 into 10 goes 5 times, 2 into 32 goes 16. Then I have this 5, I could say 5 into 5 goes once, 5 into 12.5 goes 2.5. Okay, and now it's 16 times 2.5, and that happens to be, well, 16 times 2 is 32, and a half of 16 is 8, so that happens to be 40. Okay, again, going from here to here, whatever method you want to do, you want to divide this by 100, get 1.125, and then multiply 320 by 0.125. Whatever you do, I was too poor to afford a calculator, so I do all of that in my head. Okay? Now, is it always going to be as simple as this? No. You will have questions that look somewhat different. Somebody might say to you, okay, find 140% of 1,000. 140% of 1,000. Now, we did say that 100% is the whole. So if I ask you for a number that is less than 100%, you should get an answer smaller than 1,000. But if I ask you for a number that is greater than 100%, then you expect that your answer has to be greater than 1,000, because the 1,000 represents the whole, which is 100%. So again, the method does not change. You stick with the same method. You take the number and multiply it by the percent over 100, and that's how you get it. So it is 1,000 times 140 over 100. And all you have to do is to simplify this and get your answer. This cancels that. This cancels this. So now we have 14 times 100, and that gives me 1,400. See, 140% is greater than 1,000, which is what we expected. We expected it to be 40% more. And I guarantee you, if we found 40% and then add it to 1,000, it will be the same thing. We'll see later on. So that's just finding a percent of something. What happens if we flip it a little bit? What about this situation? What about this situation? If they say to you, okay, 20% of a number is, say, 80. Is 80. And they ask you, what is the number? Yeah, that's something that is often used. Somebody trying to be smart. Say 20% of a number is 80. What is the number? How do we approach that? Well, as I said before, the process remains the same. In math world, when there's something that we do not know, it says, what is the number? We do not know the number. So in math world, whenever you do not know something, you use a letter to represent that thing, and then you unravel the mystery and get your answer. So what did we say? Let's call the number x. Let the number be x. I'm going to use the letter x to represent the number. So at the end of the day, I need to get a value for x. I need to get x equal to something. So 20% of x is 80. What is x? So that means x times 20 over 100, that's what 20% is equal to 80. When I find 20% of my number, I get 80. And all I need to do is to solve this equation so I get x by itself. So what can I do? I see, oh, this 0 cancels that 0. I see 2 is 1, and that's 5. So what am I seeing? I'm actually seeing x over 5 equal to 80. And right now you can see what's on my board, so I move the camera, and I think we're better off now. X over 5 is equal to 80. So I'm dividing x by 5, and I get 80. So in order to get rid of the 5, so I get x by itself, I need to do the opposite, because the opposite will get rid of the 5. So if I multiply both sides by 5, and later on when we're doing equations, I'll be able to expect to show you more detail about this type of stuff. But if we multiply both sides by 5, I end up with x is equal to 5 times 80 equal to 400. I guarantee you, if you found 20% of 400, you will get 80. Okay? That's what it is. So how does that ever come about? Okay, how does that work? When do you see that type of scenario? Okay. Okay, I love to get bargains. I love to find bargains. Those who know me very well know that I negotiate like crazy. I don't pay full price for nothing unless I can't get out of it. Okay? So here's a scenario. A jacket was sold for, let's use an example, say $120 after a 40% discount. What was the original price? Yes, that's the type of scenario that is real and practical. A jacket was sold for $120 after a 40% discount. Sounds like my kind of deal. What was the original price? What was it being advertised for originally before the sale, before the discount? Okay, so we take a look at it. 40% discount tells me that after you take 40% off the original, this is what is left. So if this is after 40% discount, then this has to be worth 60% of the original price, because 40% was taken off. So therefore 60% is left. That is where people make a lot of mistakes. They don't focus on what the numbers mean. This is after the discount. So what do you do with the discount? You take it off. So what is left is what remains after the 40%. If the whole was 100%, 40 from 100 is 60%. So this has to be 60% of the original. So this is a trick question, even though it looks very simple. It tricks a lot of people. So that's the price. Let the original price be X. So what do we know then? We know that this has to be 60% of X. 60% of X is 120. What is X? So we write X times 60 over 100 is equal to 120. And of course, we're talking about dollars. 60% of x is 120. What is x? So we're right back where we started. We need to solve this equation to get x by itself. So for me, 0, divide the top by 10, divide the bottom by 10. We have 6 over 10. Divide the top by 2, we end up with 3. Divide the bottom by 2, we end up with 5. So now we have 3x over 5 equals to 120. So I need to get rid of the 3/5 so I can get x by itself. So I need to multiply by 5 and I need to divide by 3 because this is 3 times x. So to get rid of the 3, I divide by 3. This is dividing by 5. So to get rid of the 5, I multiply by 5. So therefore, we end up with, if I was to come right here to the side, now shift to the side a little, what do we end up with? We end up with x equal to 120 times 5 divided by 3. And when we do that division, we get 3 into 120 is 40, and 5 times 40 gives me 200. Okay? So I'm saying that the original price of the jacket was $200. So the original price equal to $200. Okay? Now, the question that you'd ask yourself, one of the beautiful things about math is that when you get an answer, you are in a position oftentimes where you could check if your answer is correct. You're claiming that $200 is the right answer. So let's go back and look at the question and see if it makes sense. So I'm going to make a note. We said that it's $200. So let's go back and see if it works. So it's a beautiful thing when you, the student, can actually check the work. So you can be ahead of the teacher by knowing if you were correct. So what does it say? A jacket was sold for $120 after a discount of 40%. So if the price was $200 and there's a discount of 40%, what was the discount? How much was the discount equal to? If it was 40%, then it means that I need to find 40% of $200. And then I subtract that because that's what discount means. The price is reduced. So let's see. $200 times 40 over 100. I'm just checking my answer now because I'm a good student and I don't want the teacher to find my mistake. So I want to find it myself. So I'm checking to see if what I got makes sense. So what do I end up with? 0 cancels 0. 0 cancels 0. 4 times 20, that gives me 80. So I'm hearing that I'm seeing that my discount is $80. If the original price was $200 and I'm getting a discount of $80, what was my sale price? It has to be 200, take away 80, and what does that equal to? That's equal to 120, which is therefore correct. That's what the question said. After the discount, my price was $120. Wow, I was correct, and that's a good thing. So let's erase this and look at another type of question. Yes. Before long, you will know that I like to have clean boards. I love to have clean boards. I don't like dirty boards. My students laugh at me all the time when I clean my board, but that's just what I do. Okay? Here is another type of question. Pretend that you're in business. If you're in business, what's your goal? Your goal is to make a profit. So let's pretend that you're buying, what are you buying? Okay, you're buying shirts. You're buying and selling shirts. So you bought a shirt for $20 and you want to sell it at 30% higher. How do we go about it? What should be the price of the shirt? So you bought it for 20 and you want to sell it at a 30% markup. You want the price to be 30% higher. Because you're a nice person. You're not trying to kill your customers. You're trying to make 30% about it. Okay, how do we go about it? One way to do it, I'm going to try and do it in two ways so you can see how starting to get the idea that with math, there's just one way to do things. You can do the same problem in multiple ways and get the correct answer. So the most obvious way to do it is say, I need to increase that by 30%. So let's go ahead and find 30% of 20 and then take it from there. So 30% of $20 is equal to $20. Again, what is the process? We multiply by 30 over 100. And for you old school, you say, oh, that's 0.3. Absolutely correct. But because I'm a visual person, I'm showing you where the 0.3 came from. It's just so easy to show that. And what do we end up here? We end up with 2 times 3 is 6. So we end up with $6 increase in the price. So therefore, the selling price must be equal to the 20 plus the increase. So that's equal to $26. I think I was too cheap. Yeah, I think I went too cheap. So forgive me. I was just too cheap. I'm going to be broke after this because by the time I put in my expenses, I didn't make a profit. So next time I'll know to do better. Okay? So that's what 30% increase takes me to $26. All right? Now, is there another way to do it? Of course. We said that the original is 100%. And if we're doing a 30% increase, then it means that we're supposed to sell it at not 100, but at 130%. So if that makes sense, and I find 130% of 20, I should get the same answer. That makes sense? Well, let's see if it works. Let's see. So I'm going to move the camera this side so I have some space to work with, and then we'll see what happens. So 100% plus 30% increase equal to 130%. So that's the new percent that I'm looking at, 130% of the original. So that's going to be equal to 20 times 130 over 100. That's how you find a percent of something. You multiply that thing by the percent over 100. And what do you notice here? 0 cancels, 0 cancels, 2 times 13, 26. Ah, that's the same answer as we got before. That's a beautiful thing. That's absolutely beautiful. So we have just discovered that we could do it in 2 steps where we find the 30%, got 6, add 6 to 20, end up with 26. Or we could say, since we are increasing by 30%, then our new amount is 130%. And then just find 130% of 20. And that's what we did, 130% of 20. We end up with the same answer. Keep that in mind. Okay, because it can be very helpful in terms of expediting, in terms of completing your transaction quickly. You know, I always get a kick when I go to the store, and if there's some issue with the cash register, and the person working at the cash register is clueless as to what to do without the machine working because they cannot do this math in their head. So I'm hoping that you will not be one of those who get embarrassed when the electricity goes out or when the machine is not working. Okay? Let's look at another one. John bought a computer let's use a number just for the fun of it. We're just having fun. We're just having fun. So John bought a computer for, let's use say $2,400. Yes, he splurged. $2,400. What is the value of this computer if it depreciated let's use 60%. So you bought it for $2,400. Over time, the value keeps going down, keeps going down, keeps going down. And I'm asking you, if you were told that the value depreciated by 60%, what is the new value? Again, you could look at it and say, okay, the value went down 60%. So let's find 60% of 2,400. So 60% of $2,400 is equal to 2,400 times 60 over 100. Starting to sound like a tape recorder, but I think you're starting to see the pattern. This is how you do it. It never changes. Even when you become old as ever, this will still be the process. So why not just get comfortable with it? 0 cancel, 0 cancel. So now it's 240 times 6. And don't laugh at me as I go. 6 times 0 is 0. 6 4 is 24. 6 2 is 12 and 2, 14. So the new value is, sorry, the discount, 60% of 2,400 is 1,440. So the reduction in price is 1,440. So what is the value? So current value is going to be equal to the original price, which is 2,400 minus the depreciation, which is 1,440. And what does that give us? So that's 60, and that's 9. Hey, is that correct? I think that is $960. $960. Can you imagine You bought it for $2,400 and now it's only worth $960. Isn't that a shame? That's how it is, okay? So that's one method of doing it. What happens if you try to do it another way? The original is 100%. The depreciation is 60. So if it depreciated 60%, what percent is left? I think it's going to be 100 minus 60. So I think only 40% is left. So the new value is 40% of the original. So I could do the sidebar, go to the side right here, and I could say, okay, 40% of 2,400 is going to be equal to 2,400 times 40 over 100. What does that give me? This cancels that, this cancels that. So it's 4 times 240. 400, 4, 4 is 16, 4 2 is 8, and 1 9. 960. Same answer. So what have you just discovered? You have discovered that you could find an increase, you could find a decrease, etc. I'm going to take the time now and just mention a simple use of percentages. In real life, it doesn't work like that anymore, but I'm going to make you be aware of it. So if you hear the expression, you know what it is. Okay? Just bear with me a second. You know what I do. Okay? I hope so far you're with me still. Okay, here we go. There is a term in math world that is just used for discussion purposes because it doesn't apply anymore. It's called simple interest. Simple, notice the word simple. Simple as compared to the real thing, which is called compound interest. We're not doing compound interest today, but I wanted to let you know that compound interest is where the action is. This is what happens in real life. Simple interest is only for illustration purposes. Okay? I have been told that way back in the days, when consumers weren't educated, there were some merchants who charged simple interest on loans, like car loans, etc., and people didn't realize that they were being robbed. But that has been fixed. As a matter of fact, in many cases, it's illegal to charge simple interest because, in truth and in fact, it's not honest. Okay? But what is simple interest? Simple interest is saying that every year you get the same amount of interest. Or if it is a loan and it's on simple interest, every year you pay the same amount of interest. But in real life, you should only pay interest on what, if you have a loan, you should only pay interest on what you owe, on the balance that you owe. So if you borrowed $10,000, you should not be paying interest on $10,000 when you have already paid off $6,000. So that you get the idea? So simple interest is not cool, okay? But I just want to let you be aware of it so that if you see it in some question, that is just giving you a little practice with something, you know exactly what it is. For example, find the simple interest on $800 at 10% per year for 4 years. Yes, nothing complicated. So you have $800 and they're saying that they're going to give you 10% per year interest, and they want to find out how much simple interest you would have after 4 years. Well, interest for 1 year is going to be equal to 10% of 800. It's going to be 800 times 10 over 100. And I think if I do the numbers correctly, that gives me $80. Pretty cool. You must say I'm very smart. I chose easy numbers. You think I'm stupid? I'm not stupid. Easy numbers so that I can handle it. Easy numbers. I don't need a calculator. Okay? Now, the question is, how much in simple interest after 4 years? So if for 1 year it's 80, simple interest says that it's constant. It doesn't change. So it's the same amount every year. So therefore, total simple interest is going to be equal to the amount for 1 year times the number of years. So 4 times 80 gives me 320. So that would be the answer to that question. The amount you get for 1 year times the number of years, $320. Okay, that's what simple interest says. There's actually a formula for simple interest. But can I entertain you with an idea as to what is the difference between that and compound interest? Just like a teaser, maybe, just to see what would happen. Let's see what happens if it was compound interest. So I'm going to write the amount that you got because of simple interest. So simple interest gave me $320. What would the amount be if it was the real deal, compound interest? Let's see what happens. So, interest after 1 year equal to 800 times 10 over 100 equal to $80. Now, interest after, okay, interest for the second year equal to, now you don't have $80 and $800 anymore. You now have a total of $880. So it's going to be $880 times 10 over 100, and that gives me $88. So in your second year, instead of getting $80 interest, you're now getting $88 interest. Interest for the third year is going to be equal to, now you don't have $880 anymore, but you have 880 plus 88, so that gives me 8 and 8, 16, and that's 968. So I'm doing 10% of 968. And what do I get? I get minus 680. So I have 1 more year to go. I said 4 years. So what do we have? Interest for the fourth year is going to be equal to, I need to add this interest to the total that I had before and then calculate my 10%. When I add this to this, I get 80, decimal, 6 plus 8 is 14, And then this I think is 14, then this is going to be 6. I'm losing track of where I know. 8 and 6, 14. So 9. So this is going to be 6, and this is 1, 0. Times 10% gives me $106.48. So the total compound interest has to be 80 plus 88 plus 9680 plus 106.48. How much is that? So I need a little space to do this, but I think you're getting the idea. I need a little space. Do I have enough space here? I think I do. So it's 80, 88, 96, 80, and finally 106.48. This is 8, this is 2, and this is 6, 12, 21, 10, 18, 27, $371.28 compared to what did we get before? Compared to $320. So if you were charged, if you were paid simple interest, you'd have received $51.28 less than you should. So that's the difference between compound interest and simple interest. Simple interest reduces the amount that you receive. Okay? So I've given you a taste as to what percentages are. I need to transition over into ratios and proportions, which are very related to percentages. So bear with me while I make this here. Now, I should take the time to point out that there is a simple interest formula that I did not mention. There is a formula. I don't like to memorize stuff. I like to analyze and then come up with my reasoning. But for those of you who like to memorize stuff, then the simple interest is going to be equal to the principal times the rate times the time. The principal is the amount that you started with. The rate is the interest rate as a decimal. And the time is the number of years. Simple interest equal to the principal times the rate times the time. Remember we did the principal times the rate? It was 10%. So it was 800 times 10 over 100. And then we multiply it by the number of years. There it is. Principal times rate times time. Simple interest. Okay. Ratio is a very common practice in math. It's always a good practice to compare quantities. It's something that is done all the time. It can be very useful. It can give you very important information that can help you to make good decisions. For example, if you're going into a neighborhood to live and you're looking, say for example, you have little children and you're looking to see that the school system is working properly, you might want to look at the ratio of kids who pass versus the ratio of kids who fail standardized tests. Because if the majority of kids are failing their test, it might be sending you a message that your children might have difficulty succeeding in that environment. So ratios have a lot of value in so many different ways. But let's go to some simple stuff. Okay. As a kid, I used to play a lot with marbles. So let's pretend we have, say, 8 red. Used to love my red marbles. Say, 6 green, and say, 12 yellow. They could ask the question, what is the ratio of green to red marbles? That's a question you could be asked. What is the ratio of green to red marbles? Now, one of the things that I love about math is an exact science. It's not about how I feel, what I think, what I prefer. If the math is right, if you're in New Jersey, it is right. If you're in Montego Bay, it is right. If you're in Zimbabwe, it is right. That is the beautiful thing about math. The principles are foundational, and they are often theorems that are proven over extensive analysis. Notice here, it says, what is the ratio of green to red? Common mistake. Somebody look at it and say, oh, red is 8, green is 6. The common mistake is not noticing that the order is green to red. That is what is important. The order is what is important. Everything else comes second. If you mess the order up, then you're going to get the wrong answer. So in this case, notice the question doesn't say anything about the yellow. Again, testers like to throw stuff in there to distract you. I tell my students all the time that I must confess that I am committed to trying to trick you. That's just what I do. I can't help myself. So you, the student, have to be watching out to make sure that I'm not trying to trick you. So here it is, 8, 6, and 12. There will be students in some place that say, I need to use a 12. I need to use a 12. But you as a forensic scientist, you as the detective, should be able to say, wait a minute, the question doesn't have anything to do with yellow marbles. So the yellow stays in its lane. The yellow doesn't come into play for this question. So for this question, the ratio of green to red, order is important. Green comes first, red comes after. So the way you write that is going to be 6 to 8. And whenever you have a ratio like that, similar to when you have fractions, it's a good practice to reduce. It's 6 to 8. If you can divide both sides, notice 6:8. If you can reduce this, then you do so. So 6 to 8 is the same as 3 to 4. If you put your answer as 4 to 3, it is wrong. It is not correct. You have the correct numbers, but they're in the wrong position, so that makes them incorrect. So keep that in mind. Order is important, okay? Now, what does this have to do with anything? I'm glad you asked. Let's go talk about money. Let's talk about money. I tell people all the time, and you might think it's a joke, but it's not a joke. This is real. As a matter of fact, this is one of the reasons I'm so excited to do this, because it's because of learning things like these in school that I was able to make a living. I'm being honest. If I didn't learn all these crazy little things, I might have been broke. But by learning these things, I was able to build a resume, and today people think I can do stuff, but they're tricked. Anyway, look at this example. Okay. Who should I use? Let's use Michael Jordan decided to donate. Let's use a simple example. Simple example. Okay. Okay. in the ratio five to 2 to 3. So let's go. Michael Jordan decided to donate $20 million to Rosse's High School, Montego Bay High School, and Manning's High School in the ratio 5 to 2 to 3. And the question is, how much was given to Manning's High School? Okay, so that's the challenge we have. Just so you know, we talk about ratios. This takes into account proportions. So this is the amount that we have to divide up into this ratio. And this is where ratios and proportions come into play. So we talk about proportions when we're trying to decide how to divide something based on a specific ratio. All right? So how do we do this? Well, the total that we have is 20 million. And the ratio that we have is 5 to 2 to 3. Meaning 5 portions to the first school, 2 portions to the second school, and 3 portions to the third school. So the question is, how many portions altogether? What's the total number of portions? I count 5 plus 2 plus 3. There are 10 portions that are being given out. 5 of them to Rosse's, 2 to Montego Bay High, and 3 to Manning's High. 3 portions to Manning's High, 2 portions to Mobay High, 5 portions to Rosse's. So out of the total, what fraction of this is going to Manning's? Well, 3 out of a total of 10. So therefore, 3/10 of 20 million will go to Manning's. So the amount for Manning's is going to be equal to the 20 million times 3 out of 10, which works out to be what? I think that is 6. I think that's pretty cool. So Manning's will get 6 million based on this ratio. Okay? Let's try another one. Again, what was the process? We find what's the total portion, the total number of portions. So it's 5 portions, 2 portions, 3 portions, for a total of 10. And therefore, 10 portions equal to 20,000. What is 3 portions equal to? Is 3 out of 10. 3/10, 3 over 10 times 20,000, that's it. Here's another question. A piece of rope Yes. A piece of rope is, say, 600 meters long. If it is cut in 4 pieces in the ratio 3 to 2 to 4 to 3 to 2 to 4 to 6. What is the length of the longest piece? A piece of rope is 600 meters long. If it is cut in 4 pieces in the ratio 3 to 4, 3 to 2 to 4 to 6, what is the length of the longest piece? So, how many portions we have? 3 plus 2 plus 4 plus 6. I get 15 portions. The longest piece is how many portions? The longest piece is 6 out of a total of 15. So therefore, the longest piece is going to be equal to 600 meters times 6 out of the total, which is 15. And if we did this correctly, you know 15 goes into 60 4 times, so that's 40 times 6 is 240 meters. You have just been introduced to ratios, to proportions, and also to the application, simple application of percentages. I know many of you are wondering, why are we having these sessions? And I think it's important. I think it's important for us to have that conversation. As I said previously, and I'm uttering the words of many people across the globe, we are in this thing together. As I get older, there are certain things that resonate with me. And one of the things that I firmly and honestly believe in is, if you have benefited from a well, if when you were most thirsty and most in need of a drink, that well was there for you. And I'm speaking metaphorically, symbolically. If you have benefited from the well, wouldn't it be nice for you to make sure that there is water in the well for the next person who comes along? Ponder it. Think about it. If you have benefited from the well and you have been fortunate along your journey, wouldn't it be nice to make sure that there is water in that well so that somebody who came after you can drink? Well, this series of math sessions, along with our English section, if you were not there for the session last night, you can Google it. It's on YouTube. You will be amazed. I was fascinated as I sat and listened to the English presentation. So you must be wondering, why is he listening to the English tutorial? Guess what? I'm a part of this, and I found it very intriguing as I sat and listened. I was in school as I listened to Miss Dawes present that first lesson in English last night. She said it was beginning English, and I had to start asking myself the question, man, you don't know much at all. Thank God I don't have to pass an exam now, but she was laying it down. But back to what I was trying to say. If you have benefited from the well, think about ensuring that there's water in the well for those who come after you. If I appear to be tall, it's because I'm standing on the shoulders of those who have gone before me. Their sacrifices made it possible for me to be here. So as we try to give back, in your own circle, in your own experience, won't you consider giving back to somebody who could benefit from the goodness of your generosity? I thank you for tuning in, and I trust that I'll see you again as come next week, Tuesday, we'll have our next streaming of Learning Together in Math World. Thank you so much, and I look forward to seeing you. Go Brosis, Rosis Brosis. Go and learn together. Thank you so much.